Welcome to 5G Encode. Run by a consortium of industry leaders and led by Zeta Networks, the project will develop clear business cases and value propositions for 5G in manufacturing. The project will explore three 5G use cases: augmented and virtual reality for industrial applications, monitoring and tracking of time-sensitive assets, and wireless in-process monitoring and analytics. Using augmented and virtual reality to support design, manufacturing and training will dramatically improve efficiencies and reduce cost. Thanks to 5G's high capacity and wireless nature, sensitive assets can be tracked both in factory and in transit in real time, improving productivity and reducing cost. 5G's ultra-reliable, low-latency and high-bandwidth capabilities make it ideal for in-process monitoring and analytics, boosting output and making machines work more effectively. If you want to find out more about 5G Encode or are interested in getting involved, please get in touch via our website or find us on social.
Excellent. And here next to me, you can see now Vasilis Seferidis, who's the CEO and co-founder of Zeta Networks. So Vasilis, thanks a lot for the really nice contribution. And unfortunately, we only have time left for one short question. But could you please give us a little bit more insights into this network slicing approach and multi-domain orchestration that you are considering in the 5G Encode project?
A key innovation of the project is the automation of network service orchestration through network slicing and splicing. Network slicing, of course, is the process of defining isolated and virtualized subnetworks, which we call, of course, network slices, from a common physical network. Each slice is defined so it is delivering the service differentiation required to meet the end user requirements in an efficient and economical way. Network splicing, from the other side, is a new concept that we have introduced, which can be considered the opposite of the network slicing, whereby two or more subnetwork topologies are merged together to form the aggregate topology of the underlying subnetworks. It is a very useful concept that can be used to simplify and automate the provisioning and management of the end-to-end services across private and public 5G networks. In the case of the 5G Encode project, network slicing and splicing is used to deliver seamless service continuity. And I'll give you an example of how we are going to use it. One of the use cases we have in the 5G Encode project is the asset tracking service, whereby time-critical assets must be monitored both within the factory and while in transit from one production site to another, and as they move from a private 5G network within the factory to a public 5G network provided by a major telco, in this case Telefonica UK. Inside the factory, the private 5G network creates a dedicated slice for the asset tracking service that satisfies the specific requirements in terms of bandwidth and latency. At the same time, a dedicated slice is created by the telco in their own public 5G network with the same bandwidth and latency requirements. Then the two slices are joined together, basically spliced, through the network splicing process. The coordinated provisioning and splicing of the two network slices are done by Zeta Net Splicer, a multi-domain orchestrator that produces the aggregate topology of the two slices and allows the seamless delivery of the asset tracking service across the private and public networks.